Algebra 2, Set 15, Elimination. Okay, if we have an equation x plus 2 equals 7, we can do lots of things to this equation that will not change the value of it. When we solve x plus 2 equals 7, we get x equals 5. I could take the equation x plus 2 equals 7 and multiply all of it times 2, and I would end up with 2x plus 4 equals 14. And when I solve that, I get 2x equals 10 and x equals 5. So I still get x equals 5 even though I multiplied the whole thing by 2. I can also take the entire equation, multiply it by any number. So in this case, let's say 6. We get 6x plus 12 equals 42. 6x equals 30, so x equals 5. The value of the equation doesn't change when you multiply everything by the same number. You can also divide everything by the same number. And if I have x plus 2 equals 7, if I add the same amount to both sides, it's not going to change the value of the equation. So adding 2 to both sides gives me x plus 7 equals 12. If I subtract 7 from both sides, I get x equals 5 still. So we're going to use that same concept in order to help solve these equations. So we have 2x plus y equals 11 and 3x minus 2y equals 6. The first thing that stands out to me here when I'm going to solve this, we're going to solve these by elimination, and I see that I have a plus sign and a minus sign. When you're solving by elimination, that's what you want to look for. So we want to make these two equations look in such a way that they're going to cancel each other out. And so if I take this y and I turn it into a positive 2y, when I add 2y and subtract 2y, they will eliminate the y. So that's what we want to do. So we'll take the top equation and multiply everything by 2. So we end up with 4x plus 2y equals 22. And then we'll just write the second equation underneath it. 3x minus 2y equals 6. So now we can add both equations together, and we get 7x, the 2y's drop out, equals 28. And we can find that x equals 4. We can take that and plug it into one of the equations. So 3 times 4 minus 2y equals 6. 12 minus 2y equals 6. So negative 2y equals negative 6, so y equals 3. So our solution is 4, 3. We do want to check that, so we'll plug it into both equations. 2 times 4 plus 3 equals 11, so 8 plus 3 equals 11. Yes, that checks. Then we'll plug it into the second equation. 3 times 4 minus 2 times 3 equals 6. 12 minus 6 equals 6. Yes, that checks out as well. Let's do another example. Use elimination to solve. Now in this case, we don't have just a y or an x that's by itself. I'm looking and I see this positive and negative right here, so that's where I'm going to focus my energy and focus my attention. The closest factor of both 2 and 3 is going to be 6. So I'm going to multiply the bottom by 3, and I'm going to multiply the top by 2. That way I'll get a 6 and a negative 6 that will cancel each other out. So we get 6x plus 4y equals 46, and negative 6x plus 9y equals 6. Now we can add those two together, and we end up with 13y equals 52. So y equals 4. I can take that y, plug it into the top. 3x plus 2 times 4 equals 23. 3x plus 8 equals 23, so 3x equals 15, and x equals 5. So my solution is going to be 5, 4. I double check. 3 times 5 plus 2 times 4 equals 23, so that's 15 plus 8 equals 23, and yes, that checks. Check the bottom. Negative 2 times 5 plus 3 times 4 equals 2. Negative 10 plus 12 equals 2. Yes, that checks as well. So my solution is 5, 4.